Welcome to the AP Calculus AB video for skill number 110. I can simplify exponential expressions and draw connections between exponential functions. And featured below is the famous temple, the Parthenon, and the trivia question for the video is, on what hill is the Parthenon located? Alright, for this skill we're really taking a look at the rules for exponents. And there's 6 rules that I want to cover. And the first one is the rule where if you have a common base, the exponents can be added together if you're multiplying. Here's a example with numbers and the final answer of 128. The next rule for exponent is if you have a negative exponent, you can move the number and exponent from the numerator to the denominator. We've got 4 to the negative third, and that's equal to 1 over 4 to the third. Similarly, if you have a negative exponent in the denominator, you can move that piece to the numerator. We combine the first two rules to actually create our division rule, and if you have a to the x over a to the y, that would be a to the x minus y. So I've shown the example here of 5 to the 6 over 5 squared equals 5 to the 6 minus 2, or 5 to the 4th, which is 625. The next rule for exponents is if you raise an exponent to an exponent, you can multiply those two exponents, a to the x times y. So you can think of that if we had 2 squared to the third power, what we're doing is we're going 2 times 2, 3 times. So there's our 6 2's, 2 to the 6th. I showed 2 to the third to the 4th becomes 2 to the 12th. Next rule is the distributive power or distributive property of an exponent. It can distribute into each piece, and that works for multiplication or division. Moving down the page, what we have is rewriting expressions in different bases. So there's two sorts of things we should be able to do with this skill. One of them is to simplify using these rules, and the other one is to write an expression in a different base. And so what we've got here is take this expression and write it in base 4. Well, I notice that 16 is 4 squared, so I replace 16 with 4 squared, and then I apply my property where I have an exponent raised to an exponent, and what we can do is we can multiply those exponents, giving me 4 raised to the 2 times 3x plus 5, which is 4 raised to the 6x plus 10. The next one says write in base 5. So the first thing I do is I notice we have a denominator, so I'm going to move the denominator to the numerator and give it a negative exponent. And then I translate 25 to 5 squared because we wanted it in base 5. And then I apply the property of multiplying my exponent times my outside exponent, giving me a final answer of 5 raised to the negative 2x minus 14. Finally, we want to write the last one in base 2, so I wrote 32 as 2 to the 5th and applied the multiplication property, and I wrote 16 as 2 to the 4th and applied the multiplication property of exponents. And we get 2 raised to the 10x plus 35 over 2 to the 12x minus 20. And now that those two numbers are of a common base, we can subtract the exponents and arrive at our final answer.
Always with you what cannot be done. Hear you nothing that I say. You must unlearn what you have learned.
All right, I'll give it a try.
No, try not. Do or do not. There is no try.
Alright, so when we have exponential functions and we want to talk about relationships between a group of exponential functions, one of the first things that we can look at is what is our base. And if all of our functions have a base that is between 0 and 1, say we had like 3 times 1/2 to the x, and we had 5 times 1/7 to the x, the common thing that those two equations share is they're both exponential decay because the base is less than 1. Likewise, if we had two equations that had a base that was greater than 1, you could say that they are both exponential growth functions. This is a really general concept. Really, we should be familiar with being able to recognize the relationships between functions at this elementary level. Are they all decay or all growth? And I gave one example of applying our rules in a setting where we have lots of variables and lots of exponents. So the first thing I did was I distributed the 4 in, so I got 2 to the 4th, x to the 8th, y to the negative 12th, and that got rid of my exponents. And then I combined my x's, so my x to the 8 divided by x to the 3rd is x to the 8 minus 3. And then I combined my y's, y to the 10th minus negative 12. Simplified my 2 and I got 16 over 8 and simplified all that down. I kind of cruised through this example because this is a skill that we practiced in pre-calculus and should be pretty comfortable with. But if you want more examples of this, feel free to check out the Calculus BC video on this skill. Calculus BC 205. Alright, this concludes the video for Skill 110. I can simplify exponential expressions and draw connections between exponential functions. And the temple featured below, as I said, is the Parthenon, located in Athens, and the hill it's on is commonly referred to as the Acropolis or Acropolis.